Welcome, everyone, both the people here in person and online. I'm Judy Fulton, the president of the Maryland Native Plant Society. We are sponsoring this event together with the University of Maryland Extension and the Baltimore City Forestry Board. There's been a lot of interest in our program. A lot of people have signed up. Considering stream restoration, what should the future hold? So without further ado, I'd like to turn the meeting over to our moderator, Claire Cambardella.
Good evening, everybody. Thank you for joining us. Like Judy said, both to everyone who's here in person and everyone who is joining us online. My name is Claire Cambardella. I'm a watershed restoration specialist with the University of Maryland Sea Grant Extension. And tonight I'm serving as the moderator for this discussion. So just a quick reminder that the University of Maryland's programs are open to everyone. Stream restoration is a practice that's being implemented across the country in an effort to repair eroded stream systems and improve habitat and local and downstream water quality. As with any large-scale project, there's still a lot that the restoration and regulatory communities are learning about the effectiveness of the practice and how permitting, crediting, implementation impact the success of projects. To put it simply, this is a sticky wicket. Our goal tonight is to consider what we can learn from challenges associated with stream restoration and think about what may be needed to better align science, practice, and policy. So with that, I will turn it over to our panelists who are going to be presenting what they have learned about stream restoration in their capacities across Maryland and Virginia. So first up, we will have Rob Schnabel. He is the Maryland restoration scientist with the Chesapeake Bay Foundation, followed by Andrew Macdonald, who's the chair of the Environmental Council of Virginia, Erik Michelsen, the senior environmental policy officer and deputy director of the Department of Public Works in Anne Arundel County, Rod Simmons, recently retired conservation biologist, Solange Filoso, Associate Research Professor at the University of Maryland Center for Environmental Science, and Ashley Bowers, the Natural Areas Unit Manager for Baltimore City Recreation and Parks, Urban Forestry Division. After everyone presents, we will have a Q&A discussion. So with that, Rob Schnabel.
Okay, my talk is going to be about stream restoration and getting to the source of the problem and do true restoration. And I'm going to talk about the MS4 program in Maryland, which is pretty much a broken system. And most of the stream projects going on out there are to meet these MS4 credit program. Little elementary land use really quickly. So you can have the green filter, a forested land use system, where as you develop land, you get a gray funnel, more water running off the land, which causes stream back erosion. And the amount of discharge, you can see the big spike in the graph. That's after a big rain event, you get all that water coming, causing stream bank erosion and flooding issues, versus when you have a green filter system, you get a little bump in stream flow, and then everything kind of flows casually. So in terms of the Chesapeake Bay watershed as a whole, the biggest source of pollution is still agriculture, but we're making a lot of progress there. But the biggest growing source of pollution is urban and suburban development and stormwater runoff. Back in 2010, the EPA set something called the total maximum daily load, which is a pollution budget. Everybody just says TMDL. And in 2013, stream restoration was added as a best management practice for dealing with stormwater management, which started the gold rush. I want to highlight someone. Bill Stack was the co-author of the crediting system. And back in 2019, 6 years after it became an allowable practice, he wrote this, and it's somewhat damning of the whole system. He says, I can no longer hide from the turmoil that I helped create in the stream restoration industry. The panel of experts developed protocols that made stream restoration by far one of the most attractive in the Bay program's toolbox. This action unleashed an unprecedented flurry of stream restoration projects across the Bay watershed, which are being implemented by a thriving billion-dollar industry of engineers and a few biologists. And I forgot to mention big-time financiers. This is his quote. Stream restoration today is a panacea for MS4 managers to meet their commitments. The Bay Program expert panel felt strongly that as a qualifying condition to receive credit, products have to be part of a comprehensive watershed plan that also address the root causes of stream bank erosion, which is impervious cover. Municipalities are spending enormous amounts of money on projects that generate the necessary water quality credit, but have no impact on stream function. So they'll focus on that word credit for a minute. So a quick brief on MS4 and what it is. It stands for Maryland Separate Storm Sewer System. And all of our developed counties have to clean up a certain portion of their impervious acres. And if you look at the various counties and the impervious acres that they have, you're looking amongst the 10 most populous counties, you're looking at 173,000 acres that need to be treated. And so what the Maryland Department of Environment created was something called an equivalent impervious acre credit. So that's where you can use all these different best management practices as opposed to dealing with the impervious acres themselves. There's other practices that you can use. And this is where stream restoration comes in. Just as a ballpark, pretty much you do 50 feet of stream restoration, you're going to get at least a 1 acre impervious acre credit. And quite frankly, in a lot of cases, it's even less feet and more acres of credit. It's based on how much erosion, how much sediment and nutrients are coming from the stream bank. It's not based on the toxic flush coming from parking lots. It's just based on sediment and nutrients. So if you put Band-Aids on a stream bank, you're going to get that credit. An example, and you should go to your counties, go to your jurisdictions and find this data. I'm not picking on Frederick County, but I do a lot of work there, so I'm just using them as an example. Overall, they need 10,000 acres of impervious acre credit. And what you do is you get a 5-year permit. You need to address 20% of your overall acres within a 5-year period. And so you can see all the various practices that they use to meet their 5-year permit. And they used 27% was in stream projects, but only 17% were addressing true stormwater issues. And then you have all these other practices. A really popular one in Baltimore City is street sweeping, which obviously that does nothing for the water quantity issues. So this is something we worked at the University of Maryland Global Campus to look at counties throughout a bunch of the counties and see what percent of the jurisdictions were using stream restoration to meet their required goals. Baltimore County was 57%, and the big one, not setting a great example, is Maryland State Highways. 87% of their credit system is through doing in-stream projects as opposed to addressing highway runoff, which is what we want them to do. And the reason why is that most stream corridors are publicly owned, so it's cheap access. I'm going to shoot by this, but you'll have access to this, but this just goes through the number of acres they need to treat, number of acres that they did through stream work, resulting in the 85% that they used. Look at all those highways from this map. That's a lot of highways. It'd be great if we started to address some of the stormwater runoff from our highways, over 30,000 acres. So the public is angry. That's why we're here tonight. And here are the issues. What's the fuss with stream restoration? It's not addressing the source of the problem, which is impervious acres and water volume issues. Number two, sorry, those numbers are off. It's expensive and projects are failing. We have to go in and fix them over and over again because you're not addressing the source of the problem. Number three, you still get continued flooding. And once that water's gone through the flood, then you get dry stream beds. You're not doing anything for fisheries with that when you don't actually maintain the base flow and stream channels. And number four, we're clearing forests and the resource impacts during construction. This has people super duper angry. And I totally get it. I'd be angry too. Those trees are part of the solution. Every tree reduces stormwater runoff by as much as 13,000 gallons of water. So every time you move that, you're actually increasing stormwater runoff. So CBF actually filed suit. We asked MDE to please look at Baltimore County's permit and asking them to really address more of the issue. We partnered with Blue Water Baltimore for this. And what you have in Baltimore, a lot of our streams flow from the north going south. So if the folks up north, Baltimore County doesn't address their stormwater runoff, it's going to really impact Baltimore City. And that, quite frankly, that's an environmental justice issue. You've got the rich folks not addressing stormwater management, and it's flooding down on poor folks in the city. And so you get floods all the time because they're not addressing the actual water volume issues north of them. And then it's not just sediment and nutrients. It is a toxic flush. You're looking at pesticides, you're looking at organic compounds, you're looking at road salt. So it is not just sediment and nutrients. If we treat the stormwater up in the upland areas, then you can actually filter out some of these other pollutants. So I'm going to, three things that we're, right now we're still going the wrong direction. In fact, we're doubling down. These are three examples. So last year's trust fund, DNR Trust Fund, which is our wonderful flush fee monies that go for restoration projects throughout the state. DNR just awarded $7.5 million for a stream project out in Frederick County to a nonprofit. And it's going to help state highways get over 1,800 impervious acre credits. That's 1,800 impervious acre credits for going out to a farm in Frederick County, stabilizing parts of Devil Creek, and it's going to abdicate any responsibility for actually addressing the stormwater from highways. And this is last year's award, so it'll be constructed probably this year. Second, Whole Watershed Act passed in 2024 with a goal of taking a whole watershed approach, address your stormwater issues in the upland areas so that you can restore the streams and control the runoff. So there's 5 watersheds that were chosen for the Whole Watershed Act. I'll just give one example, and you should know that a majority of money, the #1 best management practice through this program is stream restoration. It's getting a bulk of the money for this. So we're entrenched and need to change the system. So here's an example. This is in Annapolis, where I live. The city of Annapolis is going to stabilize 490 feet of stream, which is great because they're going to protect a sewer line, but they're going to give themselves 43 acres of impervious acre credit. That averages out for 11 feet of stream bank stabilization to almost a football field of parking lot. Makes no sense whatsoever. And they're using the Whole Watershed Act to fund this. Number 3 here is stream mitigation. So I work mostly with farmers. I love this facility. I've come here a bunch, do lots of regenerative agriculture, converting cornfields to pastures, restoring the sponge, then fencing cows out so then we can restore stream areas. Well, the stream mitigation folks are coming out to restore these farms, putting farms into permanent easements through public dollars, program open space money, through the CREP permanent easement program or these other programs. And it's so lucrative that consulting firms are waving money in front of these landowners, offering to buy them out of their easements so they can jump in their channels and do things after we have trees that were planted 15 years ago that are now 30 feet tall on a 100-foot buffer. So this needs to change. It's undercutting progress we're actually making in the agriculture sector. And then unhealthy stream equals unhealthy watershed. We got to fix the watershed, not the stream. An example of where we've done this, we actually, the Chesapeake Bay Trust back in 2005 led out these grants called the Targeted Watershed Initiative, where we brought together partners and we actually addressed the source of the problem. And this is where State Highways actually did a great job. They addressed 2 miles of concrete flume along I-70. This is just beyond the Appalachian Trail out there, but because it's a trout stream right there. And we had all this toxic hot water as a toxic flush, killing trout there. So we had them turn this into grass swale and bioretention centers, treat the water, infiltrate it, to reduce the thermal shock to trout. And then once we did all of the upland stuff, I fenced miles of cows out of streams, planted forest buffers. We converted an inline pond that was used for irrigation for a golf course. We took it offline because that water was super hot. Again, killing a trout. Trout need cold, clean water. And then we did a stream project, but we did the whole watershed first. And the only reason we did the stream project was actually to narrow the channel so you had more coarse substrate, not silt in there, so the trout could actually spawn in it. Okay, you got to do the watershed first before you jump into stream channels. And so this is actually used in an example by Maryland Biological Streams during the Bay Program Stack meeting in March of 2023. They used this example where we didn't have many reproducing trout back in 2005. With all the watershed work, they were having huge numbers of success with trout. And trout are like the canary in the coal mine. If you can restore trout habitat, cold, clean water, we're in good shape. So last thing, this is how Bill Stack ended his letter. And you can look this up online for the Center for Watershed Protection from September 12th of 2019. It says, I'm not sure what it will take to make these projects part of an integrated plan to provide functional lift beyond sediment and nutrient credits. Perhaps this will come after we spend billions of dollars on these projects and taxpayers ask, why can't I catch a fish in the stream? And I hate that. And I'll add my little quote, not nearly as eloquent as that, but giving impervious acre credits for stream restoration will only lead to more stream bank erosion, as it will allow for impervious acres to increase. More erosion with polluted runoff equals a downward spiral. And we're not going to save the bay that way. All right, thank you.
Thank you, Rob. Andrew Macdonald is up next.
It's great going after a speaker with whom I agree with so much. My background is geology, geochemistry, and I first got involved with stream restoration not a few years ago, actually, so fairly recently compared to many of my panelists here. But there were several projects in Alexandria, Virginia. City came in and said, we're going to get these credits to meet the MS4 and so on. And we want to do all these wonderful things to the stream, and we want to stop erosion. We're going to fill it in, and we're going to, make the stream much nicer, and so on. The same story that we hear in so many jurisdictions around the region, or at least have until recently. And so a number of us got involved with the project, including my friend Ross Bailey here. And we started looking at the science behind a lot of this, and obviously became very concerned about it. And one of the things that we did, or the group did, a group of citizens did, including Russ there, they looked at where the pollution was coming from. And because, of course, the credit system is based so much on, well, the stream is eroding. We're putting phosphorus downstream. We're doing other things. Well, the study showed that almost all of the pollution was coming, as it often is, upstream from the stormwater system, from fertilizers, pet waste, you name it, from the upland part of this impervious, the watershed. And so the result of that is we stopped the project cold. And I think it's it's a very difficult thing to do, as many local activists will know. It's very hard to stop these projects once they get going. And we need now, I think, to Rob's point here, we need to figure out how to change the way we go about doing things. But I think it's really important to look a little bit at the science. And so I just sort of went back in the last couple of years. I've been trying to read a lot of the literature, because restoration, paints a good picture, though a very confusing one. And I think a lot of people are very confused about it. It sounds great. Restore a river, remove a dam. I mean, all these things we can all agree with. But in the case of the sort of restoration policy and programs that seem to exist around the Bay, it is very much tied to credit system. And it's very much tied to looking at a stream and using models to say that stream is eroding and we get these credits. But what you really find out when you go about and actually look at these credits and look at what is actually happening, they really are almost meaningless, a lot of them. There's not a lot of water pollution reduction occurring so often. And it's not really once you actually begin to look at the science, it's not so hard to understand that. But I'm going to go through a little bit of the science. I can't do an enormous amount in 10 minutes, but I'm going to try to do a little bit. So I just I called this credits without outcomes. Why has stream restoration failed to improve water quality? I think we need to understand why it hasn't. Why has the credit system failed to incentivize good watershed planning, to Rob's point? And what would be a better approach? And I'm going to start off like a journalist, and I think the better approach is upstream. I think that's where we need to start, and that's where the credits need to be given. And I think the stuff that goes on in a stream needs to be the last thing we do, the very last thing to do. Because a lot of these watersheds, and this is why people do get so upset, you go to these things, and yes, there's some erosion. But these are beautiful little, oases in urban areas that everybody wants to protect. The biodiversity is often very good. The stream has some erosion. So what? As my friend John Field, who does a lot of this work, says, yeah, but it's in equilibrium now with all that stormwater that's coming down. So it looks bad, but it isn't necessarily bad. But the real problem is upstream. Well, we know in a lot of these streams, and here's one with some erosions. Somebody's going to walk by there, if you're not a geologist, and say, oh my God, that thing is eroding away. We need to do something. That stream is in equilibrium with all this urban runoff. We go in here and we say, okay, we're going to knock down the banks, add things, connect things to the floodplain. And what does all this do? What does it really do? Well, I mean, again, I think the diagnosis is wrong. I think we need to work upstream. The scale is totally wrong. We need a watershed scale. The hydrology is wrong because we haven't really, dealt with the stormwater and controlling to Rob's point, why do these streams erode? Because the peak flows are all off, the duration of flows are all off, and so the streams naturally react and build a deeper channel. But there are things you can do now, and there's some very good scientists and engineers around the country who are talking about taking bioretention and putting in devices that control the release of water such that you control these peak flows. So in other words, you don't really need to do some of the work in the stream. What you need to do is work with the areas that are developed and the areas that are to be developed, and you need to think as it would in a watershed. If you're just, restoring a quarter mile of a stream and you think you're really doing a lot, you really are not doing a lot. What the monitoring shows, well, the ecological uplift is not great. Restorations are not very effective at improving populations of macroinvertebrates. Bernhardt National Survey of 37,000 projects, there's basically no verification of these credits. There's the methodology behind a lot of this stuff is so helter-skelter. Nobody does before and after monitoring, after projects. There was one in Fairfax with the USGS involved, which did, but that's one of the few. There are not many that really look at things in a very cohesive way. So you don't really, you're going out and saying, well, there must be that amount of phosphorus in the bank and the model says this and you get the credit and the next thing you know. And you don't do any long-term monitoring. But a lot of it is really, again, I think the problem has been the focus is wrong. It's not on that little stream area. It's upstream where we need to work. If you look at a lot of the data and you go through and look at many projects, natural channel design project, less than 7% have showed real water quality improvement. Basically no biological improvement. And even the ones that have shown some water quality improvement have shown that there are other ill effects that happen to the stream. Temperatures go up, other things go up. So even though you might think you're winning a little bit of the battle, you don't seem to be. Yes, you can stop erosion in channels. You can put wood in and you can connect things to to the floodplain. But what about in 10 years from now? If you haven't done anything with that stormwater, do you think it's not going to erode and continue to erode down the way? Of course it will. Not all stream restoration credits are equal. I think it's very interesting, if we do things that are more like bioretention, we know a lot more about how they can control, pollutants. And of course, if you put these bioretentions in the stream, well, then you're kind of destroying the stream and maybe the riparian aspects of the stream. But if you do it upstream, you can really actually come up with a credit that means something. Sorry, these are so detailed, it's too much. A group of citizens in looking at Gulf Branch and Arlington, again, looked at the stream channel that was going to be restored and to say, where is the pollution coming from? It was coming from the stormwater, not from the stream. If you have high flows, yes, you're going to start to move some sediment and you'll move some phosphorus. But the bulk of it is still coming from upstream, and that's not being slowed down, trapped, or anything. Yeah, the root cause is being ignored. I sound like a broken record. And it seems so obvious. I don't know how we've gotten to this point where we've spent so much time and money on the wrong part of the problem, really. And I think we really need to look at that question and figure out what we can do to change that. Again, I think the key to this, in my view, is to say that restoration of streams, by and large, results in an awful lot of ecological damage with very, very minimal or no positive water quality impacts. And the most important thing we can do is to shift the focus upstream, credits, energy, and so that we can actually restore the streams by changing the fluvial dynamics, the hydrodynamics, such that the stream can function more naturally. Thank you very much.
Thank you, Andrew. Up next, Erik Michelsen.
Thanks, Claire. I'm Erik Michelsen. I'm with Anne Arundel County Department of Public Works. We are one of the implementers of stream and wetland restoration projects. And I am here to offer maybe a slightly different perspective than the previous two presenters. I do find some points of agreement, and I'll try to emphasize those in my talk as I get to them. So from my perspective, I think a lot of the conversation here and the things that Rob and Andrew have said about upland stormwater management, they're valid points. That's part of our portfolio. As you saw in Rob's presentation, stream restoration was 35%, 65% was something else, or other kinds of practices. So it's not an either or, it's certainly a both and kind of perspective. But I think the other piece of this is that some of the paradigms that we approach these conversations with, in my opinion, aren't fully, don't take full appraisal of the situation as we understand it. So this is actually one of our restoration projects in Glen Burnie, just downstream of an area that was a concrete trapezoidal channel previously. But a lot of what the focus historically has been on, and this is the case with stream restoration, it's the case with sort of the way we've treated these systems in the past, has been we've approached systems like these on the top here, these already incised, downcut, oftentimes single thread systems running through stream valleys, whether it be on the side of an agricultural property or whether it be in an urban area. And we've assumed some degree of normalcy there, that a lot of us grew up playing in streams that look like that. And so that's sort of what our archetype for these systems is. As we've learned more and as the research has expanded, what we really have come to understand, especially in the mid-Atlantic region, but I think more broadly at this point, is that these stream valley bottoms historically had a composition much more like this image below. They were integrated stream and wetland systems. There was not sort of this standalone single-threaded stream. There were riparian wetlands, there was forest, there was other vegetation there. These systems were much more resilient, I would say, in terms of their ability to withstand flashy flows and their ability to trap nutrients and sediment and provide habitat. And of course, before the land was cleared after European colonization, there wasn't necessarily a tremendous amount of that material moving down, but I'll get into the details as to sort of why we understand that. One of the things I do want to point out, and I think Andrew pointed this out a little bit in his presentation, and this is a slide from folks in the stream restoration industry. This is from 2013, but the conversation's been going on for a long time. And I actually disagree with the way this slide was put together, but it was sort of a way to try to understand the way that these various components of features stack. And so historically, the industry, and again, Andrew and Rob sort of pointed this out, was really focused on making sure that these systems could stably convey water and sediment through them so that they weren't erosive. There may be some wood that was included in them. There may be some other elements of them, but there was this feeling that we don't have the capacity to modify the hydrology at what's called the reach scale. So within 1,000 or 200 feet, we can't possibly modify the hydrology of the system because that's something that has to be done at the larger watershed scale. And I fundamentally disagree with that sentiment. I think there's been some evolution in the thought process of the industry since then. And I'll talk a little bit about what that means in terms of the way we restore streams and wetlands at this point. Again, a lot of this work and that slide that I had shown previously is built on research that's been done relatively locally. So first in 2008, researchers at Franklin and Marshall University in Pennsylvania did a look at systems throughout the Piedmont, and what they found was that these historical, what are called legacy sediments, essentially the colonial agricultural sediments that had been washed off the agricultural landscape into these stream valleys, persisted in many cases in Pennsylvania in particular, but in Maryland too, very apparent in cases where there had been historical mill dams. Obviously, Howard County has lots of mill dams. You can visit these sites nearby and sort of see these kinds of things. But anyways, this allowed them to basically go back and see sort of the historical configuration of these systems. And what they found was, in fact, that these systems mirrored that image that I had shown. This is sort of a cross-sectional idea. So again, you had the historical stream and wetland complex that was buried by those agricultural sediments. Now we've got a few hundred years of sediment on top, and we've got mesic dry tree species growing on those. And this is what we think of as healthy streams based on our experience. But in fact, probably not what streams looked like several hundred years ago. One of the things that I'll point out too here is that I know there's some native plant society interest here and some concerns about plants. A lot of times what we'll see, where we'll see interesting plant communities in these kinds of systems is in these areas where we've got what's called toe slope seepage. So we've got groundwater that's moving through the system. It's being expressed in these areas, and you've got these kind of isolated high quality wetlands that are occurring. In fact, that whole bottom was high quality groundwater fed wetlands at one point. And this is sort of the remnant of what we've got there. Again, I don't really need to tell anybody about the amount of wetland acreage lost that's occurred both in the US and Maryland, but pretty clear. And I'd say that Grace Brush's work, another former professor at Johns Hopkins University, has informed our perspective a lot too. So one of the things that she's done some great work looking at pollen data over the last several hundred years. But one of the things I'll point out here is that basically the assumption or the research-based perspective that almost all of these valley bottom areas were historically beaver impounded. So areas where we've got stream valleys now, where we've got sort of these single-threaded systems, were very likely almost all beaver impounded. This is a natural history account. And sometimes you'll see that evidenced by the fact that you've got large tree stumps buried with several feet of sediment. Obviously, the tree didn't grow like that. And you see that kind of situation pretty commonly, not just in Anne Arundel County, but I think all throughout this region, indicating sort of the major disruption that was before any of our lifetimes, but that was really ubiquitous through the watershed. One of the things that we did, because we were very interested in exploring the relevance of that Franklin and Marshall data to our case, was we worked with researchers at USGS to duplicate their experiment on Anne Arundel County streams in what's called the coastal plain, so a slightly different physiographic region. And what they found was very similar. This is a gentleman taking a ground penetrating radar out, looking at those systems. They did pollen core analysis. They did radiocarbon dating of wood in those systems. And again, they found that there was this geomorphically stable pre-colonial condition, basically a big wetland buried under all of that system, massive amounts. There were areas where the legacy sediments were so deep, 15 feet deep plus, where they couldn't even hit the bottom with the ground penetrating radar. And all that material had been deposited within the last 300 years or so. And this is sort of a artist rendering based on the Pennsylvania work of what these systems may have looked like based on the pollen and seed data that they collected. And I think it's fascinating because, again, those are the kinds of systems that we're aiming to emulate with our work. This is actually a restoration site in just west of Annapolis, where it's been in place for several years now. As you can see, it varies a little bit different, or quite a bit, I'd say, from the images that Andrew showed in terms of what we're aiming for here, which is a broad integrated stream and wetland system functioning more like those historical systems. This is a beaver wetland, not too dissimilar from what we're aiming for. We're fortunate in Anne Arundel County that we've got a lot of beaver moving back into the landscape, and that's sort of the functional goal that we're aiming for with these systems. A restored site. This site's only about a year old. Again, you can see the incorporation of wood into the system to create roughness and habitat and to address water moving through that system. A beaver impounded system elsewhere, sort of just pointing out the similarities there. And this is a site where we restored and then the beaver moved in on top of our restoration site. So that's not an uncommon thing for us to see, and we consider it Mother Nature making her commentary on our sites. And generally speaking, to the extent that we can accommodate it, we try to keep them around. I will point out, and Rob mentioned this in his presentation as well, that a key component of some stream restoration, though not all stream restoration, is infrastructure protection. In these urban areas in particular, it's not uncommon to have water and sewer infrastructure that's in these areas because gravity sewers in particular rely on that low position in the landscape. Historically, the way that utilities, bless them, have tried to repair these things is dump a pile of rocks on top of that and hope they don't have to come back for 5 or 10 years until it's washed away again. But we've been able to work with our utility bureau within Anne Arundel County to take more comprehensive approaches to protect their infrastructure, to build projects that, yes, are getting us water quality credits, but that are also much more sustainable and durable and provide habitat. You can see the hawk there in that image. Again, this is right after construction at this particular site, but allow us to take a much more, I would say, sustainable approach to protecting infrastructure, as well as providing these other kinds of benefits that we're looking for. These are a couple of sites. And again, just sort of like the gradual progression. This is immediately after construction of a site in Edgewater. This is a year after construction of a similar kind of project in Crofton. And I wanted to point out, since it is our Native Plant Society here, folks, that a lot of these projects that we built in Anne Arundel County were initially intended to create habitat for some of the RTE plant species that we have in Maryland, like the Atlantic white cedar in particular, which thrives in these wet bottomland kinds of environments and the associated species with that. And then we've been able to work with DNR on a couple of projects where there have been RTE plant species, in this case, American climbing fern, to protect those species or those plants that were imperiled actually as a result of severe erosion, and to create an expanded refugia for those plants there. So that's the end of my presentation. I'm just pointing out some. This is a upland stormwater practice where we converted a parking lot to a stormwater wetland, but I think that's the end.
Thank you, Erik. Up next is Rod Simmons.
This is a little different, hopefully blending some of the good stuff that we've heard so far together. The three things I wanted to kind of touch on. Limits of restoration is the broad kind of title for this. Site selection, do no harm, and best practices. Site selection is something that is, as Andrew pointed out, is so fundamental and so obvious, but it's almost always overlooked in this with this given that we're going to do a stream project and the reasons anthropogenic that we're doing them. The main thing about this is the most of these stream construction projects in the Chesapeake Bay watershed are planned and implemented in completely the wrong places. That's the small order, interior forested, upper headwater streams, and groundwater seepage wetlands, which usually are associated with them. The practices for stream reconstruction are really applicable to large order streams and rivers, not to interior forested stream valleys. Obviously, that departs from a great misunderstanding of what small order upper headwater stream is, and exactly why these aren't the whole practice of stream construction, reconstruction, whatever you want to call it, is really not appropriate for these sites. So that's one takeaway. Another one is that these small streams, this is Taylor Run in Alexandria, It's incised in places. You'll notice that the takeaway here is that there's no alluvial floodplain along this stream or these small streams. There are alluvial benches, but they're hundreds of thousands or millions of years old. So what that means is the water hasn't, when those things were formed long ago, is mostly in glacial outwash in these V-shaped upper headwater streams. That was the last time the water actually overflowed the banks of these streams. So one of the things you hear about in all of these construction projects is, oh, we're going to reconnect the stream to its floodplain. Well, there is no floodplain here, so you're changing the habitat right there in an improper way, and also a destructive way. This is the top left. This is a project in Arlington County, Virginia, old age forest. You can see the large old age trees, large northern red oak there, and other stream bank trees. Stream is in perfect condition. This is natural condition of the stream. It's almost got no banks per se. There's no floodplain there. And this is what the property owner didn't, to using John Field's method of wood to the bank doesn't need to be stabilized. There really isn't a bank there, but to kind of delineate that. And then the county, after many years, insisted on putting in this completely inane natural channel design project, which is basically these J hooks and boulder bars, and just totally wiped out the habitat. All the trees are dead, and the wildflowers and the forest floor is gone. The soils are gone, and they planted non-native turf grass. So it's got a golf course look. Natural channel design, or NCD. And then a variant of that is the regenerative stormwater conveyance, or RSCs, or the step pool, which is basically what it is. You can see these cascading pools. They're pretty much the same thing. The main problem is they both seek to connect these small order headwater streams, which are spring fed. Now they've got, of course, stormwater runoff in them, but originally spring fed and still spring fed with wetlands adjoining them. But in all the permit applications, and one of the selling points for some in this is to reconnect it to these floodplains. Well, you can see there is no floodplain here. There's stream banks or an alluvial bench, which is small and narrow, has no functional value in the way that a floodplain along a river or a large order stream does. And so these cascading pools are coming down, and you've got that effect. Very destructive. The whole purpose is kind of bogus, because you're doing something that's not even part of the stream dynamics. And then the destruction to the community is vast. Do no harm is a major concept goal here that should be. These are living systems, just like the medical industry, of which this typically applies, but it should apply exactly to stream forests, because they're living conditions with all sorts of living organisms and such. And that's never mentioned, or if it is, it's in passing, or under the idea that we can, we'll improve it. Things will come back. et cetera, et cetera, et cetera. Here's an example of doing harm. This is an old, globally rare acidic seepage swamp, and obviously this is purely groundwater fed. It's not. It has no relationship except adding water in the form of spring water to the stream. The stream does nothing for this, so there is no overbank flooding. I spent years, I'm still spending years, up to the present moment, trying to make this case. It's as plain as day, but the permits, federal, state, to convert this thing into an alluvial overbank wetland flooding regime is in violation of the federal and state permits, yet it happens all the time. So what natural channel design in the stormwater conveyance step pools, it tries to do is to flood these things or expand them, which is, they're all really an egregious land use practice. Another do no harm, this is a no-brainer. Does aquatic wildlife matter? Well, not really. I mean, and when these folks, and of course, okay, the folks who are working on these projects aren't equipped to deal with this. It's not part of their bailiwick. Best practices, there's many, of course, as do no harm is the one of the main goals. We'll go through this thing. This is an example of really good article and case study by Tim Wheeler here in the Bay Journal, covering the last brook trout in Anne Arundel County. The habitat was destroyed for this. So here's the best practice recommendations for these projects. Hold central the overarching goal of do no harm and for keeping sites as natural and causing as little disturbance as possible. They have to be, all the conditions have to be quantified. Adopt a policy that disallows the construction of these projects in small order interior forested upper headwater stream valleys. There are ways to control water off-site. Bioretention cells, bioswales, ponds, dry basins are the most effective infrastructure for achieving this. That invasive plants is a whole other issue. And that's what we've got time for. So, thank you.
Thank you very much, Rob. And Dr. Filoso, you're up next here.
Thanks for the invitation to be here. This is a very important discussion that we are having here. And this is a very controversial, I mean, talk about stream restoration is very controversial. And I do hope that we can come together and provide ways to move forward. Anyway, so I'm here today to talk about stream restoration for water quality. I was asked to talk specifically about this because in the past 15 years or so, I've been studying streams, restored streams in Maryland and the DC area to look at whether stream restoration can really help improve water quality. And so I hope that I can, it's nice to be here to share what I have learned and also to share some suggestions and ideas that I have of how we could improve restoration. So I thought that to set stage would be kind of interesting just to to talk about, to show, or to remind us what is the definition of stream restoration, at least according to the Society of Ecological Restoration. So this is a broad definition, not just for streams, but for all kinds of ecosystems. But the definition is that restoration is the process of assisting the recovery of a system that has been degraded or damaged. And the goal is to return the system to a close approximation of its condition prior to disturbance in terms of form and function. Okay, and but then in Maryland and in DC and the region, we know that the stream restoration is also regulated. It's a regulated rehabilitation of degraded stream channels, floodplains to improve ecological function, stability, water quality, typically designed to meet MS4 and TMDL requirements to generate pollutant reduction. So restoration in Maryland, especially, and DC area, the definition is a little bit different from other places in this country and the world. So what we really want in terms of restoration, we want to transform a channel that looks like this, that is unstable, homogeneous in terms of habitat, low biodiversity, low water quality, to a beautiful stream like that, that is dynamic, complex in terms of, this is the dream. That's what we dream. And then the goal, but in Maryland, things or in the region, the goal is a little bit different. What we really want more and more is to transform a system that is degraded, that works, that functions as a conveyor, basically as a pipe that conveys nutrients, especially, and sediment downstream to a system that functions more like a pristine stream, where you have a moderate to high removal efficiency, retention, and more retention of suspended sediment and phosphorus. So we want the streams, the graded streams, to become more of an efficient filter. So it's a little bit different of what the restoration for just improving the ecosystem in general is. So in order to get to where we want in terms of restoring streams in the Chesapeake Bay region in general, we need to restore some ecosystem functions, specific ecosystem functions. So we are really designing systems to increase nutrient retention. So, pristine streams do retain nutrients. And so we want, again, to turn a stream that functions like a pipe, where there is almost no retention or no retention whatsoever of nutrients, to a system that has uptake and retention of nutrients. In terms of sediment, we also want a stream that regulates sediment transport. So it's not just exporting sediment all the time. And we also want to restore streams to regulate flow, to be able to regulate flow. That is another function of especially headwater streams. And here, just some restoration approaches that are used in Maryland and the region in general. And, the different approaches have been talked about, like the RSCs or the valley restoration. But it is, again, important to remember that a lot of these restoration designs, they're more and more designed primarily to generate credits for impervious surface under the MS4 program. Okay, so people talked about that. So given that this whole framework of getting credits, there is the big question. It has been for a long time. So in terms of at least retaining pollutants, do these restoration approaches work? And so that's what I've been doing for 15 years, just monitoring streams before and after restoration. And then I also monitor streams. I have a control site, sites like a reference stream, and then impacted stream, just to see how they function and to quantify load reduction of nitrogen, phosphorus, and sediment. So we see before the restoration how much the streams are exporting nutrients and sediment, and then after restoration, and then we compare with our reference sites. And we collect samples during base flow conditions, and and then especially storm flow, because for sediment and phosphorus, for example, if you don't collect samples during storm flow, you're missing the point. And so after many, many years of, collecting data and monitoring many streams, we have learned the main findings, very, very briefly, is that the streams, they do remove, actually they reduce, they're effective at reducing loads of nitrogen, phosphorus, and total suspended solids on the order of like 30% to 60% of nitrogen, up to 54% of phosphorus, and total suspended solids. So they do. So, but then there's the question: is water quality better? No, because the water. The loads into the streams are already like 10 times or 100 times higher. So if they are reducing the load, that the input, they are functioning well, but they are still, the water quality is not that great. And besides, nutrients can be, there is no information that nutrients are really bad for example, some fish or macroinvertebrates. But anyway, we can make the system eutrophic, which is not good. So reducing is good. Water quality is not improving all that much. Relatively speaking. And so what we observe, so this is data from the literature, the scientific literature. In pristine streams, the total nitrogen removal is in the order of 10 to 40%. This is based on study measuring total nitrogen removal and denitrification all over the country in headwater, in small streams. And so in pristine streams, there is a removal or retention of nutrients. There is retention of total suspended sediment and all that. And as I said before, the graded streams work as they function as a conveyor. What is interesting is that in streams that are restored, what I call process-based, to function better as to remove pollutants, the retention is in the order of 30 to 60%, which is higher than what you see, at least for nitrogen. It's higher than what you see in pristine systems. So I always wonder, and I guess maybe a lot of you also wonder, if we are transforming our streams into water treatment units, because they are removing a lot. And another thing is that despite all these load reductions of pollutants, they are not, as was talked to here before, there is not much of a biological uplift. And so here are some data comparing using the fish index of biotic integrity, looking at more pristine streams and restored stream in comparison to degraded. And you don't see, it's a little better, but not that much better. So we are not seeing what we are hoping. And so here, is what I think about how we can. So what I think we need to do is to move restoration designs to focus, beyond water quality and load reductions. And so one of the things that I have learned with additional research that I have been doing, besides monitoring for load, restoration for effectiveness at reducing loads, is that there are lots of trade-offs that when we design restoration, stream restoration, to remove these pollutants or to reduce pollutant loads, we are creating some trade-offs, unintended, but there are lots of trade-offs. And so, for example, we transform a lot of times a lotic ecosystem, a stream, that water that runs, into a lentic, like a lake. Sometimes we create hypoxia. I have measured hypoxia during the summer. And for example, another trade-off, in order to reconnect a floodplain, we remove trees. we need to minimize trade-off, because removing trees and creating too much sun incidence is not good. Another thing is that I also think that we need to make aquatic habitat enhancement an explicit project co-benefit goal. We don't, and we're so focused on the water quality or load reduction that we don't think about making the enhancement of aquatic ecosystem a goal, and therefore we end up losing a lot. And then we also need to focus on ecological integrity instead of water quality. So, what should the future hold? In my opinion, besides pairing restoration with BMPs in the watershed, and then implementing climate change informed design, we need to find a way to incentivize ecological recovery. And so I'll be happy to discuss with you here, but, I've been working with an economist on the creation of credits for co-benefits, co-benefits for habitat, aquatic habitat enhancement, including riparian zone forest and the riparian forest. Thank you.
Thank you. And hopefully we can get to some of those suggestions in the Q&A. So we have one more presenter this evening, Ashley Bowers. Come on up.
It's a pleasure to be here with all of you this evening. I'm Ashley Bowers. I'm representing on behalf of Baltimore City Forestry Board tonight. I am a Recreation and Parks employee with the City of Baltimore, and I oversee the Natural Areas Unit. Tonight, I'm going to talk about lessons from urban stream restorations, particularly those that we are learning and observing in Baltimore City. I want to clarify I'm not anti-stream restoration, but I'm pro doing them well and crediting them appropriately. So I'm drawing from 9 years of experience reviewing 11 major stream restoration projects in Baltimore, in addition to outfall stabilization projects across the city. And the challenges that I'm presenting are patterns that we're seeing as opposed to one-off issues. The MS4 system is structurally constrained. It doesn't just regulate restoration as intended, but it has actively shaped a credit-driven economy. And it's presenting unintended consequences of disconnecting compliance from actual watershed performance. Our goal is ecological performance, right? It's improving water quality in the Chesapeake Bay. So the question isn't whether we have enough requirements, it's whether this particular system is even capable of producing the outcomes that the requirements are supposed to represent. I'm stating the obvious here, but stormwater crosses political boundaries. Stabilizing banks that have eroded is not addressing the issue at the source. So there are some really intense limits to modeling in ultra-urban conditions. So in Baltimore City, we're facing some real challenges. We have a densely built-out watershed, limited environmental site design project opportunities. We have altered hydrology, really flashy, high-volume streams. And then we have competing priorities. We have infrastructure protection, that is, of course, extremely important in the city, but we also are working on forest preservation as a critical green infrastructure that is supporting healthy communities in Baltimore. Our remaining public natural areas flank the streams, as you can see here. What I have in green on this map are our public natural areas on parkland. They're often on steep slopes, and they have these historic and aging gravity-fed infrastructure along the waterways. So yes, conflicting interests for sure. Reducing impervious surface and converting to forest wetlands receives some of the highest credit in the MS4 program. I think that in and of itself really speaks to the importance of forest preservation. Yet in Baltimore City, We have over 77 acres of forest being impacted or deforested in the name of MS4 credits. It's oftentimes in 80 to 100-year-old forests. These are our oldest, nicest forests in the city, and they're quite exceptional. We have high quality habitat at these sites, spring ephemerals, structurally age diverse forests, and intact soils. But none of that is accounted for in mitigation with stream restoration projects, right? We're looking at tree removal, mitigation of trees. A forest is not just a tree. It's a summation of the whole ecological community, and that is being completely impacted and really truly decimated by construction activity when we're clearing an upland forest in order to access our streams and then clearing the entire riparian corridor. This is just an example of a proposed 3-acre forest clearing for MS4 credit. There is some infrastructure repair that is necessary at the headwaters, but the remainder of this project is for MS4 credit explicitly. It's a really nice intact stream, and it's adjacent to our best forest in the city. And I want to stress that the health of the forest is also really important in how it functions for stormwater management. A site like this that is then fragmented decreases the integrity and ability of the remaining surrounding forest to manage stormwater to the same degree that it is currently. Forests help to prevent flood and erosion. They serve as existing green infrastructure in our cities. We shouldn't be removing them in order to install new green infrastructure that costs us millions of dollars. These are sensitive sites. Again, they're 80 to 100 years old. In the scheme of things, to replant a forest, it's going to take generations before we have something functioning like this again. So here are just a couple of examples of projects in the city, Chinkopin Run Park. So you can see the before and after, the forest that was cleared for the infrastructure project and stormwater facilities. This is another example in Powder Mill Park where we had a 20-acre more than 20-acre forest, and you can see how much clearing was required to install this stormwater facility here. This is an 800-foot wide clearing. And I just want to point out that older growth forest loss in the city is occurring due to MS4 infrastructure consent decrees and development in the city. We're facing a lot of deforestation. So not only do we want to preserve the forests, I know that we say we're constructing this stream, it's not deforestation because we're planting trees back on site after the construction is finished. But really limited establishment is a major issue that we are facing when you have really heavy, large construction equipment coming through these sites. It compacts the soils. It makes it really difficult for vegetation to grow and reestablish after the fact. We have flashy hydrology in these systems. So we're seeing really low survival rates in Powder Mill Park, for example, 0 to 30% in some areas survival of the trees that were planted. There's rapid invasive takeover, heavy deer browse pressure, and that compounds the issue where we have to install tree cages around the trees that we're trying to plant, but that traps debris. The trees get washed out, and they also become invasive vectors. So this is that site. It was a former 19+ acre forest, and we're just having a heck of a time getting any trees to grow here. Just kind of an example there. We have practices failing within 1 year of construction. When designed in 2016, most of the stream restoration projects in Baltimore City designed in 2016, still being installed today. It was believed that those projects would hold for up to 30 years and all of the benefits that they were going to offer to the city. We now understand that they're not meeting those goals. And we also now understand that their lifespans are much shorter, 7 to 10 years, if they will hold that long. And many are struggling right off the bat. This example in Stony Run Park, where the practice failed within 1 year of construction. And again, the establishment of vegetation is critical to these designs. They're bioengineered projects. That means they rely on the establishment of vegetation in order for the projects to even be functioning as designed. And if you can't get the vegetation to establish, that is highly problematic for the functionality of the project, even in the best case scenario. So we have this budget cascades. When budgets are stretched to obtain as many credits as possible, projects are less likely to be approached with deliberate watershed scale planning and implementation. We're seeing quantity over quality as a result of the MS4 system, and this is not going to get us to our intended results. I want to point out that, there's really a closed accountability system as well with our MS4 jurisdictions. The same entities that are responsible for delivering projects are also confirming their success. It leads to limited incentive and especially capacity to really slow down and invest in higher quality implementation, and to challenge whether projects are truly functioning or not. So, I want to stress the point that interjurisdictional, interdisciplinary coordination of projects, Rod mentioned project siting is of the utmost importance. So I certainly concur with that. So what we're seeing on the ground in Baltimore, it's not unique. We've heard it across different MS4 jurisdictions tonight. It reflects a broader challenge in how restoration is being measured. I looked to like the CESR report from 2025. There's very clearly a response gap. We're not seeing the benefits downstream in the bay. There's a disconnect with the system at hand, and we need to really think critically about how we are handling these issues that we're facing. Not all restoration is equivalent, and we need to not treat it that way. Our crediting system especially should not be treating it that way. We need to align credits with the actual functioning and long-term performance. So I suggest we monitor these sites post-construction to really understand how they're performing before they are receiving credits. There's a lot of project lumping happening where we're not addressing projects and crediting them at a watershed scale. So if, it's a watershed solution, that should receive a credit as opposed to one-off projects. There's a difference between urban and peri-urban practices, so that should be acknowledged in the crediting system, and also the expectations of the jurisdictions and the different challenges and constraints that they face. Lastly, I just want to say we really should find a way to disincentivize the removal of forests, upland, and riparian, or incentivize their protection, take the positive spin. But yeah, thank you. Okay.
Thank you, Ashley, and all of our panelists. So hopefully I'm going to give you a chance to keep expanding on those suggestions, as well as Dr. Filoso's. I have a few prepared questions here that we're going to get started with. But I see we've got questions coming in from our in-person audience. Folks online, please also submit your questions in the chat. And again, we're going to prioritize those by most common question that people are asking. Our question, as we have it written here, is many jurisdictions are focusing heavily on stream projects to gain MS4 credits. Are there requirements to consider stormwater management in the drainage area leading to the stream in conjunction with the project? And so I think a lot of our panelists tonight have addressed that does not occur. And I think what's coming to mind for me is, are there practices, are there different types of stream restoration design that could be focused on? And are there upstream practices that that are being focused on to complement and enhance the stream restoration? So if anybody wants to respond to thinking about those alternative practices, especially in the context of longevity for the stream restoration. So I see Rob and then Erik.
This is on. Yep. So first off, again, just back to MS4, just think what we're talking about here. We're talking about giving, by doing a stream project, the bit more erosion happening in that stream bank, the more credit you're going to get to abdicate any responsibility for addressing more impervious acres. So think of that. And I mean, you don't have to be a restoration scientist for 30 years to understand that. Doesn't really make sense. In terms of doing best management practices, the key is the hydrology, the water, right? We're kind of taking water for granted. Yeah, on the West Coast is learning a little bit. We're going to learn too as we hit droughts. Luckily, we're going to get some rain next week. But it's all about capturing water in the upland areas, cleaning it, let it slowly infiltrate and provide base flow to our stream system, which will help with flooding issues and it will help providing water during dry periods. We tend to take that for granted, but that's what needs to happen. It's and doing that, ideally prior to the design of any kind of stream work. I mentioned that trout habitat one. We did, a whole sub-watershed of restoration work prior to jumping into a stream channel to then create the spawning habitat for the trout. It's got to happen in that order. And anytime you jump straight into the stream channel, created like impoundment ponded systems, it's almost like inline stormwater management, which you're not supposed to do. But even if it's slowly flowing through these water slowly flowing through these impoundments, you get so much sediment deposition dropping out that smothers any potential fisheries habitat there, the benthics that they were talking about, the insects in larval form that are the fish food. So you really got to address the hydrology that drives the whole system in the upland areas prior to doing anything in the stream channels.
All right. So I guess I would just to lay some context in terms of the various MS4s, and I can speak for Maryland in particular. Each of the jurisdictions, especially the large phase 1 MS4s, spent the better part probably of the first 15 years of the 2000s doing watershed assessments, detailed watershed assessments of each of the watersheds within their counties, identifying areas of opportunity for problems, and trying to figure out how do we lay out practices. Can we go into the existing landscape and retrofit existing stormwater practices and bring those up to contemporary standards? Are there areas where we can put new practices in place and they haven't existed? And are there areas where we've got sewer line exposures and severe erosion and that sort of thing? And that forms the basis and has informed the basis for where various jurisdictions have cited their practices. Sometimes there's landowners who don't want to cooperate. Sometimes there are opportunities to do that kind of work. And I think every jurisdiction that I'm aware of in Maryland does some range of project implementation, including upland practices, in addition to stream restoration and the other kinds of things that folks have mentioned here. I think one of the things that I kind of want to correct or maybe rebut is the idea that these systems themselves are not sources of pollution. They very much are sources of pollution, whether that's the result of historical land use and development, and a lot of it is. They are themselves sources of pollution. So even if we were to do everything that Rob has described in terms of, trying to infiltrate water up at the source, trying to get it into the ground, trying to reduce as much volume as we can, many of those areas are still going to be sediment and nutrient contributors, even if we've shaved off significant amounts of volume. That's not to say that that's not something that should be achieved, but it's saying that if we don't do interventions at these lower positions in the watershed, whether it be outfalls or stream areas, stream wetland areas, we're going to be pretty dissatisfied with the results at the end of the day, because these areas themselves are sources of some of the pollutants that we're trying to address.
I think it's a more pernicious issue than that. I mean, in Virginia, for instance, the grants that are given to a city like Alexandria, the city of Alexandria, are for the stream restoration. They're not given the grants to work on bioretention, collecting, water, doing these kinds of things. So there's an immediate effort. That's where the money is going. The money is going toward these things that seem easy. And part of it is, where do you have free land that you can work on? A park. You can go and destroy a park, tear it up, claim that you've actually solved the water quality problems, either of the stream, or maybe let's argue that we're collecting a little bit of the stormwater. That's where you go to do your work. So there's very little effort put into looking at upstream, and it's more complicated. I will agree with that. But I think in the end, it's a much more efficient, cost-effective to use bioretention and other things upstream ultimately. And again, to the point that a lot of the panelists have made here, if we can figure out, I think we need to stop thinking we can restore these urban streams. Yes, there's an historic context of glaciation, history, agricultural, you name it. But if you fix the hydrograph, if you can control the water flows going into these streams, they will heal mostly on their own. We don't have to do a lot. Then we can save the forests, which should be saved, which are doing the recycling. So I think it's just we've really got to figure out how to get the funding in the right place and make the upstream piece the number one thing you do. And you've got to prove you can do it and not just say, hey, Alexandria said to us recently, well, we just can't really do too much. Well, yes, we're going to do some, they have to get the first flush. They have to do a little bit of collection of nutrients. But you can collect nitrogen, phosphorus, heavy metals, all sorts of things very effectively. So I think we just need to work at that. And some of the people like, I don't know if it's Bledsoe or Lammers, and I think it's Bledsoe in Colorado or whatever, but working on these systems where you design a bioretention system with these baffle systems that can help control the duration and longevity of these peak flows so that you can get the hydrograph a little more normal. I mean, it's never going to be completely normal. And I think the idea that we're going to bring these back to some pristine, whatever the heck that is really, I don't know what that means. And I don't think any of us really do. I mean, yes, we can think of colonial times, pre-agriculture, to point of Grace Brush's work at Hopkins. But I think that we need to focus much more intensively with money and effort upstream. And I think we can do an awful lot if we do that. And then we don't have to worry about the stream so much.
May I say something? Even if we go to the streams, because of the creditor system, I don't know if I'm saying right, but it's much more, you get much more credit if you go downstream. And even in terms of nutrient removal and load reduction, it's much more effective in terms of a percentage of pollutant reduction if you go to the very top of the headwaters. And a lot of times these headwaters that we call the headwaters, they were not even headwaters because a lot of times there was so much erosion because of stormwater that these headwaters became longer. And so in a way, we don't even have to worry, in my opinion, that we are degrading a stream because, there are some areas I've seen in DC where, the storm water pipe, whatever, was moved. And so there was a stream here, and then then they made a stream elsewhere. And that was restored. And so I just wonder how much, if we do look enough at opportunities of going upstream, in terms of streams, of channels. And another thing I want to say is that I have monitored also some stormwater BMPs, and together with restoration, in terms of efficiency at removing or reducing loads of pollutants, the most effective was not a stream restoration, but a swale. You probably know, Erik, that was right behind the giant supermarket. That is it's just like an indentation, a swale that used to be grass, along a road, and it used to be grass, and then it was, planted trees there. The thing used to have, to contribute to stormwater to a creek nearby. And after 2 years, there was no water whatsoever anymore going out of that place. So anyway, it's a longer road. I just wonder, I hear a lot about we don't have access to, land and all that, but I wonder how much, I mean, maybe I'm being naive, how much more maybe we could do. I don't know.
We'll take one more, from the panel, one more response from the panel, and then we're gonna switch topics.
Great. Yeah, I'll be brief. So yeah, it's certainly a challenging topic talking about upstream solutions in Baltimore City. But in my first map, I was showing the upstream solutions don't start in the city. They start in the county for most of our watersheds. So not to say we shouldn't take responsibility for that in the city. We should find other solutions. But I think just in terms of the crediting system, we need to take a very real look at that. Just because we can't find enough space in a dense urban environment for these practices, should we be forcing the jurisdiction to be obtaining these credits? I mean, it leaves us kind of with stream restoration as our option. That's what we still have access to. So we're forced to do that in some ways. Street sweeping isn't the solution either, but I just think it really warrants a broader conversation and taking a slightly different perspective in our dense urban areas, perhaps. And then I do also just want to note with the pollution that's being contributed by the streams themselves by way of sedimentation, just one important thing to keep in mind is that during stream construction, the sedimentation that occurs from those projects is not monitored, but it's extreme, it's excessive, and there are daily sediment releases into the stream during those construction practices. So I think it would be really beneficial to have some monitoring during construction to really get a very clear sense of, is erosion of the banks here and there over a 5-year time span even contributing as much sediment as during the actual construction window? Question. Thanks.
Lots of great questions, even coming back from our panelists. So we do have a bunch of questions coming in about non-native invasive plants, native plants, what's being done to protect trees after they go in. So we kind of want to address that. So I guess the question here is, what are the questions to ask restoration contractors to size up how they plan to maximize planting survival rates and minimize development of invasive plants? And then another question here is about how to monitor and manage non-native invasive plants prior to a stream restoration practice. Bob, would you like to respond to that first?
Good question. The short answer is there is no funding. There's no poorer cousin in this whole process than the ecological restorationists. Just take the word ecological out of there, because they're never at the table before, during, or after. But certainly once everybody's been paid and the project's done, these things, the term, and this is from the industry folks themselves, folks like myself who work for design and build firms, they call these things microstegium highways or Japanese stiltgrass highways. Once the job is done, everybody scatters, goes about their own way. There's no monitoring. There's no ecological uplift, or that's a fancy word for improvement, ecosystem improvement. Invasive plants, there's no funding for it. We're lucky if we get funding, and this is large scale landscape level funding. This is not volunteers or, a beleaguered staff working on something. This is, a big company that specializes in this 9 to 5. And there's just no funding for that. We all know that. Anyone who's worked for government knows there's just no funding, even the wealthy governments, so, and you need 6 figures at the minimum, hopefully 7 figures to do that. So that's just a given. And we can dream about it or think about it, or it's great in the specs. But the other thing is, it would behoove the design and build industry if they did pay attention to that, because it makes these projects look all that much worse. And all the money was spent on the native plants we put in there, and all the ecological uplift is just for naught. And when we're asking also the regulators, the MDE or DEQ, DNR to a lesser extent, certainly U.S. Army Corps of Engineers, these guys are not equipped. They have lots of great ecologists on staff, but they're not making the decisions in these projects. So these guys, so we don't have, it's like talking a different language to them. It's just not something that's in their bailiwick. So that's not going to change. Not to sound, the title of this is "Where Should We Be Going" or whatever. That's a place we're not going to go, sadly to say.
Schnabel was up next, and then we'll go to you, Erik. Thank you.
I was just going to say something even before the plant thing. Your first question should always be, how many impervious acre credits is this project going to get? All right. So you understand the trade-off for them going in and the impact you're going to see. What are you no longer going to treat? Is it a couple shopping malls worth of parking lots because you're going to come in and do this? So that's the first question. It's not to do with native plants, but understand it. And a lot of people giving the tours of the projects afterwards, or when you're talking to the consultants, they don't mention that. You have to drag it at them. So how many impervious acres? Know that, because then you're understanding even more the trade-off of what you're investing in, because a lot of times landowner interest determines where the project's going to be. Okay.
I just wanted to respond to Rod's comments a little bit. I mean, I think there are some valid points there for sure. There are monitoring requirements. There are Army Corps and MDE or DEQ permits that are for each of these projects that traditionally have about 5 years of post-restoration monitoring required in terms of plant survivability. The contractor, to the original question, I actually don't think the contractor is the right person to ask those questions of. The right person to ask the questions of is the design team and the jurisdictional project manager representative. So the contractor, though, is on the hook generally for about a year for plant survivability and that sort of thing. What I will say is that, as one jurisdiction, we do a lot of adaptive management, where, as Rod had mentioned, we're doing native plantings of shrubs, herbaceous trees in these sites. And, as we look and see what happens or what doesn't happen in terms of survivability, we've looked at other options in terms of wetland seed mixes and looking at alternative strategies to try to capture those sites more effectively before invasives become an issue. I think wherever you've got disturbance, you've got the potential for invasives for sure. But I'd also say, again, in terms of our approach, one of the key features for keeping invasives at bay is hydrological changes of the site. Sites that are wetter tend to have a lot less invasives in them than sites that are dry and disturbed and have wood chips spread on them or that sort of thing. So there are certainly best practices, I think, from the industry that we could all learn from, and that each of us tries to implement as we get more projects in the ground.
So I want to respond to a couple of things. One being Baltimore City has it better than most in terms of the restoration requirements, I would say. 1 year of establishment of vegetation post-construction isn't going to get you where you need to be. I guarantee that. In Baltimore, we have a 2-year post-construction warranty for tree establishment, and we have just completed an agreement between the Department of Recreation and Parks and Public Works, where Public Works is funding the development of a program for us to ensure 10 years of post-construction integrated vegetation management at project sites within natural areas on parkland. And I would recommend that other jurisdictions adopt something similar. It's not going to correct the issue. by any means. It's going to mean more herbicide on the landscape, frankly, but in order to get these sites to establish, that's what's necessary because of the invasive pressure. Again, that's, I think, a good solution for projects that have to happen. You know, if there's infrastructure repair needs. But generally speaking, that would be an optimal practice. Yeah.
I just want to say something about, I didn't have time in my talk, but I have been working with, a colleague economist about, trying to find ways to incentivize, to give incentives to projects that are better than others. Because, projects that will enhance habitat and including the riparian corridor. And so I wonder, because I don't understand enough about the approval, but what I understand is that the officials that give permits to projects, they kind of fly blind, and they go by how much it's going to cost and how many impervious acres it's going to treat, whatever. But I know that I've heard that they want to have more to go about, and I also have heard from practitioners. There are some well-intended practitioners that want to do a better job with stream restoration and minimize impacts to riparian zone, whatever. But they are competing, for money and impervious, area and all. So we are trying to work on a system that can give credit for co-benefits for habitat. And one of the co-benefits for habitat includes, one of the measures would be also, to give incentives or, credit to projects that have some kind of a management program for, making sure that riparian forest is not destroyed, and even if it's planted, that it thrives and all that. I don't know how realistic this is, but
So it's an interesting point. I think I certainly support it. I think one of the things that's maybe missed here a little bit is that the whole crediting system is in fact based on a very rigorous effort done by the Chesapeake Bay program that was based in science. Several local researchers served on those panels, whether it's stream restoration or agricultural buffers or floating wetlands or oyster aquaculture. All of those kinds of things went through a multi-year rigorous review. And the credits that we're talking about here, the nitrogen, phosphorus, and sediment reduction credits, were all derived through that process. And so the idea of doing bonus credits, if you want to say that, for co-benefits, I don't think there's a jurisdiction in the state that would object to that. We'd all love to have that co-benefits. We had that conversation with MDE before our last permit, and who pushed back on it was actually the environmental advocacy groups. They didn't want us getting overly credited for the projects that we were doing, and somewhat rightfully, the credits are supposed to be directly related to water quality benefits, and so adding public education or adding native plant expansion, that kind of thing, is very hard to make tangible. So I think that it's a sticky conversation. It's one that certainly I think many people would be open to, but there are many facets to the conversation that can not really be handled in a forum like this, that I think we need to be aware of and need to be mindful of. But at the end of the day, I'd be hugely supportive of an idea like Solange is proposing.
Great. Moving on to our next question. So I'm trying to combine a few here. But I think there's curiosity among our participants tonight about how often kind of washouts or blowouts or failures occur in these projects, and then who's on the hook for paying for any remediation or adaptive management that needs to occur afterwards. Erik, yep, go for it.
So in our case, all of the projects, projects that we build, the county is on the hook for structural maintenance. We have a restoration grant program. We have a lot of nonprofit organizations that do similar kind of work. They build similar kinds of projects. We assume structural maintenance responsibilities for those projects as well, because there's a recognition they likely don't have the financial capacity to fix those things should something go wrong. To Claire's original question, I think again, there's been an evolution over time. We've seen a lot fewer of our projects need to be repaired or need us to go in. That, not to say it doesn't happen. Sometimes it does happen. Sometimes older projects will come under our radar that need to be addressed. It's really like any other piece of infrastructure. Sometimes there are repairs that need to be made, and in our case, we're fortunate to have the resources to do so. But I think generally speaking, it's probably going to be, unless there's some kind of contractual relationship that requires the contractor to have that responsibility into the future, that really can only fall probably on a local or state government in terms of having the resources to do that kind of repair work.
I think a related question. Well, I think there's a tip here that I'm going to read. I was not aware of this funding, but someone wanted to offer that Maryland DNR Chesapeake Bay or Chesapeake and Coastal Bays Trust Fund has a new adaptive management grant program for Maryland DNR funded projects. They have to be funded by DNR in the first place. Funding in the range of up to about $30,000 for continued maintenance is available. So new program, check that out. And then we've also got some questions about monitoring. So Erik, someone mentioned about what's required on the permit. When the project goes in, there's a certain period of monitoring that occurs after construction. So Ashley mentioned, having some monitoring during construction would also be useful. So this question is very general. What monitoring should be done or would be helpful? And then, if it's not being done, why isn't it, or why is there pushback on monitoring? Ashley, you want to go first?
Sure.
Great.
So monitoring is not occurring within the streams prior to design, at least in the city. That is due to budgetary constraints for the individual projects. When we're not monitoring the streams in and of themselves, we don't have a clear understanding of what the volume flow of water is looking like in these streams, especially during flashy large storm events. There are projections and they're modeled for those individual streams. But each stream looks very different in the city, especially in a dense urban environment. So we don't have a really strong understanding of the condition of the streams prior to their actual design. So that would be really beneficial to be monitoring, conducting long-term or multi-year monitoring of a stream before the construction actually begins. Monitoring during construction, again, I mentioned the, sedimentation of the stream. That would be something that I would recommend we as an MS4 community begin doing so that we can hold jurisdictions accountable for the sedimentation that may occur during those projects. And that would further incentivize minimizing that and ensuring that practices are done in an effort to minimize sedimentation during construction. Post-monitoring, yes, there is some occurring where we're looking at the vegetation that's growing, but when it's not, I ask, what is really happening in those instances? Because I am seeing a lot of that in the city where, trees are overrun with invasives 5 years out. The JPA is signed off, it moves on, and the stream corridor is overrun with dead trees covered in invasive vines. So yes, we may be monitoring those sites, but who's holding a jurisdiction accountable for those? And what is the actual solution in the event that vegetation is not establishing properly?
It's extremely difficult to do very detailed monitoring of, say, water quality. In other words, if you're going to go and measure all the chemicals and nutrients that are being produced by the stormwater into the stream system, and then trying to figure out what the stream is actually generating, it takes a good deal of work. And there have been several examples recently in Arlington and Alexandria where citizen scientists like Russ over here have measured trying to figure out what part of the nutrients and so on that we're seeing are coming from the stormwater and what part's coming from the stream. And in the two cases of Taylor Run and Taylor Run in Alexandria and Gulf Branch in Arlington, almost all of the pollutants, the nitrogen and phosphorus, were coming from upstream. Very little from the actual stream itself. Yeah, now if you have high peak flows, you're going to start to move some of the sediment from the banks and so on. So you do have cases like that. And I really think the credit system, the modeling, and I know there's been some, yes, there's been expert panels that have modeled and they've looked at Pennsylvania soils and they've done lots of things. We looked at those same data and calculated the credits, knowing what the actual composition, just of the composition of the soil was in the creek versus what the credit said. They were nowhere near close. In other words, the credit was vastly overestimating the benefits of what supposedly would happen if we dumped all these tons and tons of soil into the stream and tried to reconnect it to its floodplain or whatever else. And again, to my point that I made earlier, is that we know for a fact that the stream, which is in equilibrium with this new channel, it's very difficult to regender this new channel such that you completely do away with the impacts of all this stormwater flow. So I think we're vastly overestimating what we're accomplishing, and I think we can vastly simplify it. I'm not saying we shouldn't do in-stream restoration, very simple stuff. It should be the last thing we do. And I think if we just simply do that, I mean, this is a Gordian knot, stream restoration. It's like this nightmarish thing of practitioners and some science, and they're all sort of not meshing very well. And I think we need to really just cut to the chase and start really focusing on the things that are much more effective and do much less damage, to Rod's point, much less harm to these natural systems that do a lot of recycling on their own.
I'd like to be able to take a question or two from our online participants. So we are approaching 9 o'clock. We have about 10 minutes left. Our panelists have agreed to stay for about 20 minutes past 9. So if the audience is up for sticking around for a little bit longer, we will have those 20 minutes. If you need to leave at 9, I'll pause then as well to let you know what time it is. But let's move on to a question from our online participants.
So people listening online have actually been doing a parallel discussion. People are sort of panelists at home and back and forth, whether they're private individuals or representative of other agencies. But here's an interesting question that hasn't been discussed yet. I'd be interested to hear speakers' thoughts on Maryland Senate Bill 688, which was introduced this past session. As I understand it, the bill would have made it harder to do high-impact stream restorations and required post-project monitoring of ecological, biological outcomes. Would this policy approach be useful for addressing the problems that have been highlighted today?
Familiar with that bill? Want to tackle that? All right, we have the Sierra Club in the house. I'm going to turn to our panelists first, but yes, please see our friend from Sierra Club over here when we're done, if you would like. Dr. Filoso, I would like to turn to you first.
Yeah, no, I'm not familiar with the bill, so it sounds very nice. And one of the things that I think it would be, it's one of the biggest problems, in my opinion, with stream restoration is that we use, for example, MBSS to determine what streams are degraded, in terms of habitat, macroinvertebrates, fish, whatever. But then we don't monitor, or we don't, account for high impacts afterwards. And a lot of the restoration, I know that, there is a lot of restoration that creates warmer water, too deep pools where water becomes stagnated and anoxic, too much sun incidence and all. So anyway, having something like that would be definitely very helpful. Yes.
Let's go with Erik and then to Rod.
I thought it was a bad piece of legislation. I've testified twice against it this session. I thought I understand where the intentions are coming from. In fact, it was built on legislation that was passed a couple of years ago that put some significant additional requirements in terms of public notice, in terms of some monitoring and other kinds of steps that local jurisdictions would take that had only been in effect for 6 months by the time the legislative session started. So there really was no opportunity to see whether or not that previous piece of legislation, the whole Watershed Act that Rob mentioned, it had a variety of features, but some of them were associated with this, had not even had time to go into effect and really to see what the impacts of that were before trying to layer some additional requirements in place. And so, again, I understand where it's coming from. I don't think it was well considered, and I think that there are ways to address the concerns of that legislation through practices and processes that already exist.
Thanks. I helped draft our testimony with Judy and with Sharon on behalf of the Maryland Native Plant Society. A corollary to that bill would be, what we're up against, as Erik just described. If you go to Maryland Assembly, you're going to find a bunch of guys in suits out there, powerful lobbyists, a lot of money. We'll take what we can get. We're not doing things gratuitously or just throwing out little things, but these things are so hard fought and won. Any little crumb helps. Overarchingly, though, Andrew's right. In my opinion, this is the last thing we should consider. It's putting the cart in front of the horse, really. As far as actual monitoring is concerned, you've got monitoring for different things. There's deliverables for monitoring that are in the permits and things like that. There are things that are not in the permits usually, like invasive plant monitoring, removal. These are all extremely cost prohibitive, as Andrew mentioned. The 2-year warranty on trees bumps the whole project into a very costly, a whole other ball game that almost is a deal breaker for a lot of jurisdictions. I know when I was working for the City of Alexandria, I had project implementation contact me in a fret saying, they want us to do a 2-year warranty on all the vegetation. I don't know how we're going to be able to do that with what the cost, what's been allotted. And then there's the ecological monitoring, like aquatic wildlife. And that's where the science really gets loose. You've got folks out there who are saying, and everything gets kind of dumbed down and cutesy at that point. It's like, the critters are back. Well, there's a bullfrog. I mean, bullfrog, sorry for it, will live in a toilet bowl. But you're not going to get brook trout or creek chub or, most of the others, crayfish, the native crayfish, living, back in those systems, largely because the benthic zones, you've got the gravel, the sand, all those are gone. So define monitoring, what that really means.
Good question. Do we have another question from our online folks? And we're at like 3 minutes of 9. If anybody's.
This seems to be directed to Mr. Geology, as the person says. My stream is so incised that it has begun to erode down to saprolite. It is entirely disconnected from its floodplain, which, as you know, would provide attenuation and nutrient cycling. So during heavy storm flows, the stream runs high, fast, and turbid, which, as you know, makes it very hard for critters to survive or thrive in such conditions. What exactly would you do here? Even if you reduce the upstream storm water sources, the stream is still way too wide and disconnected from its floodplain. Tell me, how would you make this stream more habitable for critters, please?
Well, of course, I haven't seen the stream, and I don't know the entire the watershed, what it really looks like. I guess the way I would answer that is that sure. I mean, we look even at like Taylor Run where I live. When you have huge storms, it does look a little muddy and flashy. You're moving sediment, even though it may not be down to the saprolite, but you're moving Cretaceous clays or whatever else the water can get its handle on. But it's a very temporary thing, and I don't think you don't look at just how incised it is, how deeply the channel is. I mean, again, that channel is developed in response to those flows. In other words, it's gotten wider and deeper, and so on. If you fill it and try to connect it to its floodplain, what you end up doing is changing the slope of the stream. And what do you think that does? That's going to start to increase the rates of erosion again. So I'm not saying you can't do things in stream. I mean, John Field, does a lot of this stuff, a practitioner and more than a practitioner, he's a fluvial geologist. And I think that's the other point I would point out. A lot of the practitioners don't know a great deal about fluvial geology and so on. They take a course from Rosgen or something like that, and they become practitioners of the thing. So I think there are things you can do in stream to control erosion. You can use wood and other things. You can do some more delicate stuff. But I think the problem is still primarily dealing with development and all of the ramifications of development and the need to control the water. And this gets us to the question of banking of all of this stuff, banking of credits. What do you think? Do you think that's really pushing us in the right direction? Or is it just continually, this same system of credits without really verification, without real necessarily function? So it's not a perfect answer to the questioner, but that's what I would say.
I'm going to pause there since we are at 9 o'clock. And I think that question is just a good example of how complex this issue is, that we are coming at this issue from many different perspectives. We're looking at the geology, we're looking at the water quality, we're looking at the plant communities, the longevity of the projects, the funding, the crediting. So the organizing committee wants to make it very clear that we hope that this is the beginning of this discussion. These questions that you've submitted will be used to generate ideas for the next event. So we want to thank everyone for coming tonight and for participating online and for sharing your thoughts and ideas and dedicating your time to this issue. So we're going to return back to our online questions, and then I've got like 2 more here, I think, that we'll try to get to.
Okay, this person agrees that Chickapin Run project in Baltimore City was, sure, something. What do you think specifically should the city have done differently as regulatory agencies and stewards of their own property?
I don't think the issue started with the Chinkopin Run project. I think the drivers of the crediting system are, something that need to be evaluated first and foremost, because, in the city, we're chomping at the bit to obtain credits. So Chinkopin Run was an interesting project because it was coupled with a sewer restoration as well as a stream restoration. So there was infrastructure maintenance taking place, but largely the size of the access road is extensive, and as a result, the compacted soils lead to really serious challenges with establishment of vegetation after the fact. At that time, there was no integrated vegetation management commitment for the post-construction period. So, there was weeding around the trees that we're planting for the first 2 years of establishment. That was required, but as many of us know, invasive plants don't only target the, base of the tree. So, that is one thing that the city is working to address is, the long-term invasive management, which, would have been beneficial for portions of the project where establishment was challenging. But ultimately, I think there were stream design failures. I can't speak to them in great detail, but there were blowouts. There were sections of the stream that just did not hold. So everything from just a stronger budget for priest monitoring, really strong budget for the design phase is critical to the success of these projects. It was such a vast, expansive site that, monitoring during construction is really challenging because there's so much ground to be covered. But having more inspectors on site on a daily basis would have benefited the project. And then again, after construction wraps up, again, it's such a vast site that to catch small issues here and there is really difficult. And if you're not catching a installation issue, that maybe is not following the design to a T. If you don't catch that early on, the contractor will continue their work downstream, and it makes it all the more challenging to ever go back and address an issue. So even if it's constructed wrong, if you didn't catch it, there just might be, construction blunders that take place. And that's a pretty common occurrence to where it's really hard for the city to go back and convince the contractor without a change order on the contract and adding money to go back and address the issue. So there's a lot to that project. I would say a lot of room for improvement and things that, shoulda, coulda, woulda. But, I'd like to say there are lessons learned from that project, but again, because so many of the projects were designed at the same time as Chinkapin Run, they're still being installed today as they were designed 10 years ago. We're really working to kind of slow that down and reevaluate some of those projects, but we need to improve the practices, and the stress of credits for the city needs to be reevaluated so that we can slow down as a jurisdiction and invest more in a project by project solution.
That was a very specific question, but I do want to give another panelist a chance to respond to it. Erik.
So obviously I don't know anything about Chinkapin Run, but I do want to respond to a point that Ashley made there at the end, which is the credit, the sort of race for credits, or whatever you want to call it, the sort of the credit driver of the MS4 permits. It is a real and it is a serious issue. We're currently in the process. The MS4 jurisdictions are currently in the process of having conversations with MDE right now about our next permit, probably going to be administratively extended a bit. But one of the things that we have asked for is a bit of relief in terms of the amount of work that needs to be done in terms of the credits generated, and for some local ability to have some flexibility, call it like sandboxing essentially in the permits to do jurisdiction specific activities. So in Baltimore City, for instance, one of the issues has been, could they use their MS4 money to be doing more aggressive inspection of their sewer system to make sure that there is not infiltration or exfiltration of that system into local groundwater or surface waters and that kind of thing, and get credit for that activity, or get sort of the equivalent of credit for that activity. Anne Arundel County, we've got sort of a different focus. Frederick might have its own focus, but some relief in that regard I think would inevitably allow there to be more thoughtful and better implemented projects, as opposed to sort of the credit chasing that Ashley's describing. But again, there's a trade-off there. There's folks who would not want to have that conversation, but I think it's an important topic to broach.
Go for it, Rob.
Yeah, I think things have changed since the pandemic. I mean, you look at stores and the amount of parking spaces we have and brick and mortar stores. I mean, let's be creative to get at the impervious acres. We may have more parking spaces that we need in a lot of those areas, which is an opportunity to do green space. It's all about increasing the green filter, getting that up there. It's getting hotter. We've had a couple of 90-degree days the other day. This is a way to make our cities, our urban, suburban areas more livable when you're planting those trees. So it's a win-win. Look at those opportunities and don't look at some of these other practices that don't address the impervious acres. Let's not get distracted about dealing with impervious acres. That's what this is about. The bigger green footprint we have, the better our whole system, our quality of life, everything is going to be. So look at these opportunities. Look how things have changed. Drive by your shopping centers. Wow, look at all these empty spots. Or working with state highways, other opportunities, or redevelopments. People aren't going back to the office anymore. And I know we need more housing. That's going to be a big push for some of these areas that may not be that busy. But look wherever they're redeveloping, where there's opportunity for a bigger green footprint.
We've had a couple of questions about floodplain reconnection and wetlands. So I'm just going to read this as it is. Should restoration efforts focus on floodplain wetland restoration, even if this results in marsh plant communities that lack trees? So we have been talking a lot about removal of trees for these projects, but in the case where wetlands are restored, what should the focus be there? Dr. Filoso, you look like you were going to say something, and then we can turn it to.
What I was going to say quickly, I think in some cases, I think it is going to be important to restore floodplain wetlands. And one of the reasons, or even, the stream wetland complexes, I don't think, I'm against removing trees and all, but in some cases we need that, especially because when it comes to some contaminants that are really nasty, these forever contaminants, one of the things that we know in science is that it's very hard to remove those contaminants, and wetlands are the only, it's like the best option because of incidence of light and microorganisms and also uptake by plants. So I think that when we start dealing with looking at removal of these nasty contaminants, we're going to need wetlands. And so I think they are good, but I think that there is an exaggeration of how good, in terms of getting credit sometimes for nutrient removal.
Wetlands? Erik? Absolutely.
So to the question, I would say absolutely yes. I think, we've had a lot of conversations here again about trade-offs. I think if we look at sort of the landscape, including the natural resource landscape, the mesic forest habitat, obviously we're losing that as development occurs, but it's pretty widespread, even through metropolitan Maryland, and certainly as you go into Western Maryland and that sort of thing. The non-tidal wetland habitat, it's almost non-existent. It's a very, very small fraction of what it was historically. The state struggles with opportunities to have wetlands mitigated. There's some of that going on the Eastern Shore because it's a relatively low-cost area to do wetland restoration. But through the Western Shore, that habitat type is very rare. And I personally think that the idea of replacing some upland forest habitat that's inappropriately in the location of the stream valley can reasonably be swapped for wetland habitat, and that is a net benefit to the resource.
Rod?
A couple things to consider there. Again, we're dealing with ancient landscapes here. For the most part, we're not talking about parking lot. Those are all great points about, I'm going to back away to, I think what this person is trying to get at here as far as okay, so you like more of a like leapfrogging out. So okay, so is is okay to turn this wetland into something else or this stream into something else. No, that's violation of the permits, the federal and state permits for number one. You can't do that. You shouldn't do that, and it's incompetent work if you do, and you could get fined for that, but because it's a taking it's forbidden in the it's impermissibly authorized. It's not authorized, and that was one of the slides I showed of the acidic seepage swamp, which is purely groundwater fed. You can't turn a groundwater fed seepage wetland, which most of these things are. We don't have tidal wetlands in the uplands, as we all know, but so why plant you can put a farm pond in, sure, but not in the middle of a forest, and certainly not in a V-shaped ancient upper headwater stream valley. People need to realize what they're dealing with in the landscape. People are looking at these things as just like a stream. Well, they're not all just a stream. There's types of streams. You don't turn a perennial stream into an ephemeral stream or a low discharge stream. That's a violation of the permit as well. We've seen that all over in natural channel design and RSC to a lesser degree converts those things because they fill the incised channel in, and then the water is so shallow and it's just a rocky, like a western stream, that it's more like a river, but it's very shallow, and so everything dries up and either cooks in there or just dries up. So that's, again, this is all just devil's in the details stuff, but it's just totally none of it monitored, none of it's checked in. The plans are stamped because it's an industry, and so I would say, that no, it's not okay to do that. You can. I mean, I'm all for creating wetlands, but in an area like a parking lot or an old farm field or something like that, where you're not going to do any harm to something other than some pasture grass, and that sort of thing. That's where those things should be built, not in the type of slide that Ashley showed us with that beautiful Baltimore forest. I don't know if that's Leakin Park or whatever, but that's the wrong place to put it.
I think that maybe there are some, I mean, I agree with you, but I think that if you're going to put wetland, whatever, in a floodplain wetland, you need to have some information about whether or not that was a wetland at some point. I think that what happens, I think a lot of times we just kind of assume things that we don't know. I remember, going with Grace Brush, to some streams in Anne Arundel County, that were transformed into a wetland, stream wetland. And she said that those systems existed, based on paleo ecology, whatever, existed in some place, but not everywhere. And so we needed to, we need to know where they are, they should be put in or not. And we are just kind of going, well, that's based on information. And again, I mean, there is always the discussion of what we really want. I mean, I understand what you're saying, I completely, but I think that we have some problems that wetlands can help us solve. And so I think that we should consider wetlands. And a lot of times, as I said before, I know top of streams, sometimes they were not even streams before. They were just what we called wetlands. They get, they are humid and water saturated during rain. And then they were transformed into streams just because of erosion. So I think, so you think that is wrong? Yes. Why?
They all, upper headwater streams begin as springs, groundwater seepage, for the most part. Now, I'm not talking about a parking lot out of Walmart where you've got that like a 10-year-old thing like that. I'm talking about. I mean, I've surveyed hundreds of these things all throughout the region. So I mean, my job, I worked for the classifying these things for the United States National Vegetation Classification. I know what I'm talking about here with a firm underpinning of geology and geohydrology as well. So
Well,
these things are not erosional. They have become erosional, but they didn't start as we're not getting our water from that. I can assure you.
Well, you know, what I'm saying is like based on, you know, Sean Smith and Peter Wilcox's, you know, work, you know, Sean Smith, for example, he's a geologist, and he mapped some streams in streams in Maryland, and there was a paper, I don't remember the, you know, the title of the paper, but that shows how much some stream networks got elongated because of erosion. And so in those cases, in my opinion, you know, they were not streams. And so if we do something to kind of bring the water table up and all that, I don't see that it's a problem. I don't think we can do it everywhere, but that's what I'm talking about.
Water table up. Water table.
I have data measuring water table going up.
So I think this is a great note to end on. Is my mic on? Yes. Because I think it's just defines that there's a lot we still don't know. There's a lot that we still want to learn. So I really want to, I'm excited to keep this conversation going. Thank you again for being here tonight. Please, if you have any more ideas, thoughts, questions, put them on a note card. We will collect them. We're going to keep them. And I wish everybody has a safe drive home, good night's sleep. Thank you all for being here.